This phenomena is called work hardening. So what causes work hardening? That is the question. Chanakya Pandit says, Tadane bahavo guna, lalane bahavo dosha. Chanakya Pandit said, meaning is that if you are strict with your child will develop very good qualities. So when you beat any material will become stronger. When you beat any material, beating the material so that stress goes beyond the yield point. When you are beating any material, somehow material is becoming stronger. Tadane bahavo guna. So what is happening? What exactly happens when you load any material and the stresses goes beyond the yield point? Number of dislocations in the material increases. Number of dislocations in the material increases. How exactly dislocation multiplies? This explanation was given by two scientists, Frank and Reed. That is called Frank-Reed source. That how upon beating the material, Frank-Reed source develops. One dislocation multiplies into 2, 2 into 4, so immediately there is a dislocation forest. Alright? So when you cold work any material, number of dislocations in the material increases. Alright? As we must have studied in strength of materials that in this region, which law is valid? Hooke's law. Hooke's law is valid in this region. And in this region, which law is valid? Power law. Power law is valid in this region, and the power law is sigma F is equals to K epsilon raised to power n. Sigma F is a flow stress or true stress. K is called strength coefficient of a material. Epsilon is a true strain, and n is the work hardening exponent. This work hardening exponent is a very important parameter for any material. It's a property of material which you cannot change it. So when the value of n is high, then upon cold work in the material, there will be more and more dislocation multiplication. So what is that characteristic which produces more and more intensified dislocation forest? It's a work hardening exponent n. For steels, the value of n is approximately 0.3, but for aluminum, the value of n is approximately 0.05. So it means aluminum doesn't undergo work hardening, but steel does. Suppose this is the stress strain diagram of steel, because value of n for aluminum is very low. So stress strain curve for aluminum will be like this. Work hardening will be insignificant for aluminum. So upon cold working, how much dislocation multiplication material undergoes, it is the property of material. And more amount of dislocation multiplication material undergoes, more will be the increase in strength of material. How? Let us say this is the material, these are the grain boundaries, and as we discussed before that whatever is the disorder, it will be pushed towards the grain boundaries. So the new dislocations which are being formed due to cold working. Once again, what is cold working? When the operating temperature is less than 0.4 Tm. Tm is the melting point of any material. So when we are operating below this temperature, it is called cold working. So whatever dislocations that are being formed, these dislocations will pile up at the grain boundaries. Whatever new dislocations that are being formed will pile up at the grain boundaries and create a dislocation forest. Interaction between the two dislocations are repulsive in nature. How? Suppose there is a dislocation here. There is a dislocation here. There is a dislocation here. So, since there is an extra half plane, so this atom is forcibly present between these two atoms. So, what you will find, a compressive strain field will develop in these atoms. But these atoms fall apart. Is it not? So there will be always tensile strain field below the half plane, and in the half plane there will be compressive strain field. So wherever there are dislocations, there will be compressive strain field. Why? Because there is an extra half plane is present. So suppose there is no space, but forcibly you are trying to insert one atom. So certainly there will be compressive strain field, and below the line there will be tensile strain field. So when this dislocation is approaching another dislocation of the same type, two compressive strain fields will repel each other. When one compressive strain field is approaching another, there will be repulsion. So that is the reason we say interaction between the two dislocations are repulsive in nature. So by cold working, the dislocation forest has been developed at the grain boundaries, and when the load is applied further, let us say dislocation within the grain tries to come out. Dislocation within the grain is trying to come out, and as the dislocation approaches the grain boundary, this grain boundary dislocation forest will create a back stress. Because interaction between the two dislocations are repulsive in nature. So when the two dislocations of the same type face each other, there will be repulsion, and the intensity of repulsion will be decided by the intensity of this dislocation forest. Larger is the intensity of dislocation forest, more will be the back stresses produced by the dislocation forest at the grain boundary. So as a result of that, larger stresses will be required by the dislocation to come out through this dislocation forest. This increases the strength of material, and this phenomena is called work hardening or strain hardening. Tadane bahavo guna. When you, in the cold condition, when you beat any material, strength of the material will increase due to development of this dislocation forest at the grain boundaries. Development of dislocation forest at the grain boundaries. Is that clear? Now, let us say we are testing any material and yield point is, let us say, 200 MPa. Okay? And ultimate tensile strength is, let us say, 800 MPa. Just we are taking an example. Okay? And we are loading the material somewhere in the work hardening region. Let us say in the middle. So when we are loading the material somewhere within the work hardening region, let us say the stress at that point is 600 MPa. So the meaning is, these are the back stresses developed by the material. How much is the back stress? 400 MPa. Is that clear? So when we load the material up to this point, let us say A, 400 MPa back stresses has been developed within the material. But once again, what is that back stress? The stress by which this dislocation forest is trying to oppose the movement of dislocation within the grain. Now you do one thing. After loading the specimen up to point A, immediately unload it. Immediately unload it and the load in the opposite direction. Let us say initially you have loaded the material in tension, you unload it and load it in compression. So initially these back stresses were opposing the movement of dislocation. Alright? But all of a sudden when you have started loading the material in compression, these back stress will now support the movement of dislocation. Is it not? Previously the back stresses are opposing, but now when you have loaded the material in opposite direction, these back stresses will oppose the movement of dislocation. So as a result of that, yield point in compression will appear prematurely. Yield point in compression will appear prematurely. What is the meaning of that? Let us say in compression yield point initially was 1000 MPa for any material, but 400 MPa residual stresses or back stresses were developed. Under that condition, yield point will appear at 600 MPa. So when you are unloading the specimen from the region of work hardening and reloading in compression, due to development of back stresses, yield point will appear prematurely. This phenomena is called Bauschinger effect. This phenomena is called Bauschinger effect. Is that clear? So there are different ways to increase the strength of any material. One is alloying, second is work hardening. But work hardening depends upon which material. What is the work hardening exponent N? There are some material which doesn't respond to dislocation multiplication phenomena like aluminum, but steel does. So when you process the material in cold condition, number of dislocations increases, and these dislocations which has been developed, they pile up at the grain boundaries and produces a back stress. Hence larger stresses will be required to move the dislocation through these dislocation forest, and hence we call it strength of material has increased. This phenomenon is called work hardening or strain hardening. Clear? There is also a third method to increase the strength of any material. There is a third method to increase the strength of any material, and that is grain refinement. That is